Hi everyone. Today we'll be taking a look at the question add two numbers from Leetcode. So this question basically asks you to add two numbers, um, and the numbers are given in form of linked list. So if we look at example 1, so the number is actually 342 and it's written in the reverse order. It's given in the reverse order and in the form of a linked list. So 342, you have the lowest ones position in the first node, and then you have tens position at the second node, and then you have hundreds position in the third node. Similarly, you are given another linked list which is also in the similar format, and you are given to add these two numbers. So if we add 342 and 465, the answer is 807. 342, 465, the answer is 807. So yeah, so this is basically the question, and the output is also you need to output in the like reverse order. Um, so output will be 7, 0 and 8. Um, yeah. Now, how to approach this question? So this question is all about like implementation. The logic, if you think about it, is simple, and the implementation is kind of similar to merge sort. If you know the implementation of merge sort, the implementation of this one is also going to be very easy. Um, so so yeah, to add these two numbers, there are three scenarios that can occur when we try to add this. Add to linked list basically. So one scenario is like at a given position, let's say one's position, both the numbers have a node, like both the linked lists have a node. That is one scenario. So in that case, you will just add the two nodes. Otherwise, there can be a scenario where there is a node at this position for the first number, and there is no no node at this position for the second number. So that is one case we need to handle, and there can be another case where the second number has a node at position but the first number doesn't have. So that's another case we will need to handle. So if we handle these three cases, then we should be able to solve the question. So to do that, we basically take like we access like the values at each of the nodes, and then we add both of the values, and if the value of like the sum is greater than 10, then we say then we calculate a carry. Sorry, I made a mistake. So when we are adding like each of the nodes, we also add to it the carry. For initially the carry is 0, like when we are starting at one's place, the carry is 0, but after we add, let's say 2 plus 5, we add, it is not greater than 10, so we won't generate any carry. But for example here, 4 plus 6, 4 plus 6 is 10, which is like greater than equal to 10, so there will be a carry. So carry will be 1, and to calculate the sum for this position, we say whatever the sum is, if it is greater than 10, then sum equals to sum minus 10, right? So we will store 0 at this position and we will take 1 as carry. And at this position, carry is 1. So 3 plus 1, 4, 4 plus 4, 8. So the sum is 8. So this is how you generate the sums. And also you need to, like once you generate the sum, you also need to create a node. You need to create a linked list along with it, and like keep on storing the numbers. So this is basically the gist of it. Um, so coming to the implementation, this is going to be very similar to merchant implementation. That is like we start from a so P1 is basically the pointer to the first linked list, and P2 is the pointer to the second linked list. And we say until and P1 and P2 are not null. Like they keep on incrementing, and until both of them are not null, we continue doing this loop. So, like I said, the sum is the value, both the values plus carry, right? That is the sum, and carry we initialized as 0, right? So that is the sum, and if the sum is greater than 10, then we say carry equals to 1, and then we reduce the sum by 10. And if the sum is not greater than 10, then we need to set the carry to 0. And then we create a new node. And for the answer list, like my answer is stored in the answer list is stored in answer. If the answer is null, like for the first time when we are initializing, if like no nodes have been created, like whatever new node that we create using the sum, that will be my answer. So answer is basically head. Answer is head for my answer node. I mean answer list. Right, and we will also need to initialize the pointer for like the answer node to new node. But let's say if like we already have some nodes in the answer, then we say okay, then we say like from the previous, like let's say there has been 7 already present, so we are creating 0, 7 is already present, so we create a link from 7 to 0. That you can do is like p3.next equals to new node, and then we also move the pointer, we move the p3 pointer ahead. So after we link them, we move it ahead, so that like you can do the cycle again while iterating. So after you have done that, we also move like the p1 and p2 pointers, because let's say we added 2 plus 5, now we need to go to 4 and 6, right? So yeah, we move that also. So we keep on doing this until when like both of these both of the linked lists have nodes at the corresponding pointers, like p1 not equals to null and p2 not equals to null. But we also need to take care of the case when one of them is null. Let's say we were given like just 2 4 3 as input, and 5 6 4 was not given at all. So we need to still find a sum, right? So that would still be like the resultant would be again 2 4 3, but you need to like do it like in the code, right? So to do that, we do like this similar thing while p1 not equals to null, and this time we just need to take care of the carry that might have come from the previous summing. So we do that, and sum is p1.val plus carry, and if it is greater than 10, then we again say carry equals to 1 and sum equals to sum minus 10. Just like we did here, similar stuff, and everything pretty much stays the same. Like this logic is pretty much this logic, and this time we just increment p1 equals to p1.next, because we don't have a p2 is already null, so we don't care about p2. Yeah, so this is the scenario when like the first link has nodes and the second link, this linked list, doesn't have nodes. And this is like the scenario when second list has nodes and the first list doesn't, which is like mirror of this logic. It's other than like instead of P1 we have P2. And last but not the least, we also need to take care of the carry. Let's say after all the addition, we still have a carry left, and we need to take care of the carry. So in that case, we need to create a new list node, and we basically attach the list node to the new node. And for the carry, it can only be one, so we put it as one, and then we finally return the answer. So yeah, so this is add to numbers. Hope you find this useful. Thanks.